Okay, we'll get started right away. I've got a lot of content today. I'm going to talk about JRuby 10, give you a little bit of intro, and then talk about where we're going with development. I'm Charles Nutter, Charlie. I've been working on JRuby for the past 20 years. There's some contact information for me if you need to reach me. I mentioned here we're seeking a new additional sponsorship for JRuby. I'll talk a little bit more about that later on. So first of all, a little intro to JRuby itself. So JRuby, of course, is Ruby, but running on top of the Java virtual machine. We try to focus on making it a Ruby implementation first. We want it to feel like Ruby. We want everything that Rubyists are used to work correctly. But we get many benefits from running on top of the JVM ecosystem. Generally, we expect that Ruby code should just work. Anything that's pure Ruby should work exactly the same in JRuby as it does in regular CRuby. We do have a different extension API. We have our extensions written in Java or other JVM languages. We don't support forking, but we do support parallel threads. So you can do all of your concurrency, all of your parallel scaling with one process. Thousands of production users all over the world running JRuby. Millions or billions of requests are running through JRuby every day. And we've had production users for over 17 years now. The only alternative Ruby to ever have that kind of deployment. So I mentioned the advantages of being on JRuby, or advantages of being on the JVM. We get world-class garbage collector support for free. We get native JIT compilers for free. Being part of the JVM ecosystem means that Ruby can also inline with all of JRuby's native code, all of the extensions that we write. It all optimizes together. We get all of the monitoring and profiling tools that are available for the JVM to work on Ruby, and you can profile Ruby code just like you would any other JVM language. We get to deploy anywhere there's a JVM, which basically means anywhere. All platforms have some form of JVM, and JRuby runs on almost all of those just fine. We've also got a huge team of people out there that are constantly making the JVM better. We don't have to do a lot of that work. I don't know how to write a garbage collector. I would not be good at writing a native JIT, but we get that benefit just by being on the JVM. So our current release is JRuby 9.4. We're on 9.4.7 right now, I think. This is our stable release right now that will be continue to support it until probably 2026. We're going to release JRuby 10 this year, and we usually go another full calendar year after that for support. It's compatible with Ruby 3.1. It was a big jump forward from JRuby 9.3, which was only a Ruby 2.7 compatible implementation. It supports as far back as Java 8, but this is probably the last release that's going to support that old versions of Java. There's lots of ways to install it. I don't need to go into all these. You've all used them before. RVM, Ruby build, Ruby install, they all have support for JRuby. That's the easiest way to get it. But there are specific packages for different operating systems, installers. You can just download a tarball and run it, all of that. And like I mentioned, thousands of users worldwide, billions of requests being processed by JRuby. Some example users. Kami is a tool used by teachers for giving homework assignments and receiving the completed assignments back from students. All of that is done with PDFs, and all of those PDFs, millions upon millions a day, are being processed and generated by JRuby. Daytech out of Norway builds point-of-sale systems using JRuby on a custom version of Android. Point-of-sale terminals at the Oslo airport. The airplane refueling terminals are actually a JRuby application. It's probably the most terrifying use of JRuby that I know of. And ad kiosks and other things. Google has a business analytics platform called Looker that uses JRuby. A company local to my hometown in Minneapolis area, Kinetic Data, does a business portal system based on the Remedy system, all based on JRuby, using JRuby to allow users to script this automation. So we really want to know who's out there using JRuby. Sometimes we never find out until we break something. So we'd love to know when it's working well for you. A little bit about how JRuby handles compiling Ruby code. We start on the left side here with Ruby code coming in. We parse that and compile it into our Ruby intermediate instructions, intermediate representation. Then we interpret that for a while, similar to the bytecode interpreter in JRuby. Eventually, we find methods that are hot, and we turn those into JVM bytecode. And then the JVM does a similar process, continues to run this code, re-optimize it, and turn it into native code. So just by compiling it to JVM bytecode in the right way, we can get a native JIT for Ruby. It's kind of interesting to see the composition of different pieces of the Ruby implementations. This is roughly where JRuby stands as far as native code, Ruby code, and now a little bit of Rust code coming into the compiler and the JIT. Similar transition here for JRuby. Again, our native code is mostly Java, but we also do have some C code, some native libraries, and we use a lot of the same standard library written in Ruby that JRuby does. And the fact that we are on the JVM, I mentioned JRuby code, Ruby code, the Java code we write inside of JRuby, all of our extensions can all inline and optimize together. So here's a comparison of one extension, OJ, the fast JSON library. We basically did just a line-by-line port of the C code for OJ to a JRuby version. And this is the performance difference that we get. It's exactly the same code, but running on the JVM and inlining with the Ruby code gets us this much of a performance boost. We also can do much better on scaling applications. Because you can run a single JRuby application for your entire site with tens or hundreds or thousands of concurrent users, we're able to scale much better with the available resources. We can use all of the cores in the system, and we can do more requests per second based on how much memory you're using. The Java platform also has a number of toolkits for doing graphics and GUIs, and of course Minecraft, the Java edition, is written in Java, runs on the JVM, and this is an example of a plugin that was written in Ruby to increase the number of chickens that comes out of an egg. But these frameworks are all available for you. They will all run across platform, and you can build GUI desktop applications and graphical applications in JRuby that work across platforms. And speaking of platforms, we also have a toolkit for building Ruby applications for Android called Rubato. This is a little example of Rubato IRB in the middle, basically a full-featured IRB running on an Android device. And then there is another application here that's just showing various little functions of Ruby being called from an Android interface. Okay. So getting on to JRuby 10, which is really the interesting part of this talk here. So this is another big leap forward, our biggest leap forward since JRuby 9000 several years ago. I mentioned that this is Ruby 3.3 on the modern JVM. We actually decided that since we're going to release later this year, we're going to do Ruby 3.4. So we may actually have a release of 3.4 compatibility before JRuby releases 3.4 compatibility. We're caught up right now and tracking changes as they're made in the JRuby repository. We are integrating the Prism parser with complete features. All of the language features are available. We'll be doing optimizations, and I'll talk more in detail about all of these. Now is a great time to contribute to this. So JRuby 10, we did consider doing JRuby X to make it cool, but that brand has kind of been tainted these days, so it's going to be just JRuby 10. Okay, so I mentioned Ruby 3.4 support. We are going to be Ruby 3.4 compatible when we release later this year. The language specs and core specs are high 90% passing right now. We're working our way through the JRuby test suite, which has additional tests. But like I say, when we see pull requests merged into JRuby, we're implementing the same things on JRuby. We just landed chilled strings for automatically frozen strings throughout the system, and we're tracking everything that goes into JRuby. Generally the same bundled and default gems. Where there's a C extension, usually we have a JRuby version that has a JRuby extension, or we just use a pure Ruby version. Sometimes the pure Ruby is just as fast and we don't need to use a native extension for it. I say we're released right after 3.4. We'll see if we're done when they do the final preview of 3.4. We might just release then, and then let people try it out and let us know if anything's missing. So the Ruby parser, I mentioned that we are integrating the new Prism parser, which is a C-based parser. We also will continue to maintain for one more major release cycle our Java port of the standard Ruby C parse.y. We do believe that the future is Prism. We really want to support this library. We don't want to have to keep porting the parser over every time there's a new release. Currently, we will ship native builds of Prism for most of the major platforms you will run on. We do have a very clever fallback in case there is no native library shipped with JRuby, in that we will run Prism as a WASM build on top of a WASM runtime on the JVM. It actually works. It passes all the same tests and language specs. I would not say it's very fast, but it would be enough for you to get bootstrapped on that platform. And actually, you can turn on Prism now in JRuby 9.4 if you want to try it out. So now, the fact that we've managed to catch up on compatibility over the past few years means that we can start focusing on a lot of optimizations that we've put off for many years. We always focus on compatibility first, so fixing user issues, helping users get JRuby into production, keeping up with new features in Ruby is our top priority. Now we can actually do a little bit more interesting work for optimizations we've been holding off for many years. So a couple examples here. One of the things that's been tricky for us, there's a number of core methods in Ruby that need to be able to read state from the caller. So for example, the __ method and __ callee, they need to be able to read the method name that was called. The block given method needs to be able to go to the caller and see if it was called with a block. These are normal methods. We call them and they deepen the stack, but they need to be able to read back up the stack to get that information. And that's difficult to do on the JVM. So in order to support that, we have to put that information somewhere on the heap. We have it available for the method. We clean it up afterwards. It hurts our optimizations, and it costs quite a bit for us. So let's take a look at an example benchmark of doing the __ method call. So this is JRuby 9.4, JRuby with YJIT. These are both based on current JRuby master, so pretty much preview 1. And then I'll show JRuby 10 in a minute as well. So we start out, JRuby gets 2.5 million iterations just calling the method over and over again. JRuby by default still is a little bit better than JRuby, even though there's a lot of overhead. YJIT is doing pretty good here. This should be basically free. This should be very inexpensive to find out what the caller's method was. The YJIT optimizations are making this quite a bit cheaper for them. If we look at what's happening in the actual JRuby bytecode, we see this number 5, we're loading variable number 5 on the stack. It's passed in, that was the method name that we were called with. We push a frame that has that stack in, that has that name from the stack available. And then when we call __ method, it knows where to go in JRuby to find that information. But this is a lot of overhead, pushing this frame every time, popping the frame off. We've already got the JVM frame and the JVM call stack. Ideally, we wouldn't have to do our own frames on top of that. So the magic sauce for most of JRuby's optimizations is a feature on the JVM called Invoke Dynamic. Invoke Dynamic lets us basically define new instructions for the JVM. The JVM sees an invoke dynamic in the code, it calls a callback in JRuby, we tell it what to do, how to optimize that code, and then from then on, it's optimized as though it was a regular piece of static Java code. It can be very, very fast. The vast majority of JRuby optimizations use invoke dynamic, and if you look at the bytecode we generate, it's almost all invoke dynamic calls to our own special instructions. So here's the example if we use our invoke dynamic tricks. Now we're loading the name on the stack, but instead of just calling the method directly, we call this special frame name call site that knows about the frame that's been called from. We put the method on the stack. Once we get in there, it decides whether to call a normal method. Maybe it's not the underscore method we expected. If it is the one that's built into core and it needs that frame name, we can call a special version, don't have to push the frame and use that overhead. So going back to our benchmark here, JRuby versus CRuby YJIT, the reason I had to blank this out is because it ends up pushing the results quite a bit further down. And like I say, when we get to numbers like this, where we're doing many times more calls per second versus YJIT, what's actually happening here is this is now free. The method name is passed on the stack, we can get it immediately without any overhead on the frame, and it's considerably faster. The other example I mentioned is the block given call that needs to be able to see if the caller was called with a block. CRuby with 2.6 million, JRuby 6.4 million, CRuby YJIT, again, a big jump. This should be a fairly cheap operation to find out if the caller was given a block. But again, JRuby pushes these results way down again, from 18 million to 240 million requests per second. And of course, this is just indicating that we've made this a free operation. We're not breaking JRuby's standard optimizations that should make this method call very, very fast. The other optimization I did recently was to improve string interpolation. You might have seen the talk earlier this week about optimizing string interpolation in CRuby. In JRuby, one of the biggest problems was the amount of bytecode that's generated. If you have an example, something like this, with just 3 dynamic elements and 3 static elements, we end up getting a tremendous amount of bytecode out of it. This is a lot of repetitive code here. We create a buffer for it, we push a frozen string on the stack for foo, we append that into the buffer, we load a value and make a dynamic string out of it, we push that into the buffer, and so on. A lot of repetitive data here, and all of these static pieces of the string don't ever change. So this is a lot of overhead and a lot of extra bytecode for no good reason. But it's very similar to what CRuby does. We push the static version on the stack, we push the dynamic elements, and then we cram them all together at the end. But it's a lot of bytecode, the JIT has to deal with this, it has to push all of this stuff onto a stack or put it into registers and then do the operation. So how can we improve this? Well, by using invoke dynamic, we can modify this so all we do is push the 3 dynamic elements, we do a special invoke dynamic that builds a dynamic string, and we embed all of the static pieces into that instruction. So now the instruction can optimize how it builds the string based on all of the dynamic pieces, all of the static pieces, and we have much smaller bytecode for the JVM to optimize. So, other tricks that we can do here, we currently make a guess at how large the buffer could be, but since it's now an instruction, we could profile and decide that's not a big enough buffer, we're usually going over that, create a bigger buffer to begin with and avoid doing as much copying. We copy the static strings directly into that buffer, so we don't have to create any intermediate objects like CRuby does. We take the static bytes, we shove them into the buffer, and there's no extra allocation involved. We also have a trick where if it's a known appendable object, like a string or a number that know how to write their string data, we go straight to the object, we don't create an intermediate string, and they just put their contents right into the buffer. So these are very simple tricks that we can use inside our build dynamic string instruction, and they translate to very good performance for string interpolation. The only 2 here that are close with YJIT are the 2 at the end that are doing all the 2s calls. And in that case, the benchmark is dominated by the strings created for 2s. So there's many more optimization opportunities that we have for JRuby 10. There are other special variables like $tilde, $_ for regular expression matches, and the last line that was read from an I/O. There's lots of closures, blocks that have variables that are only ever read. We can just pass those on the stack. We can optimize it so that we don't have to go back to the heap to get that information. We can inline methods and blocks all the way back to the caller so that every version of each, for example, will inline with the block that it was given and optimize correctly. We're also working on smarter object shapes. JRuby was actually the first implementation to do specialized shaping of objects. So if you have an object with 4 instance variables, we'll make it 4 wide. If it has 10 instance variables, we'll make it 10 wide. But we don't have any way to evolve it if new variables come in at runtime. That's something we're going to be implementing in JRuby 10. There's also tons of different kinds of calls that we don't even optimize in inline. Super calls, for example, are a whole process of looking up the method, making the call, and then doing that every single time. Those will be inlined and optimized in JRuby, and performance will be even faster than it is now. So the other thing we're focusing on for JRuby 10 is to make better use of all the modern JVM features. I mentioned earlier that we're going to be supporting, as a minimum, Java 17 or possibly Java 21. One of the features that comes in Java 21 is much better fiber support. So Project Loom is an OpenJDK project to introduce real fibers into the JVM itself. So in the past, JRuby has had to use regular native threads to implement fibers. And now this just doesn't scale. If you want to have thousands or tens of thousands or hundreds of thousands of fibers, most systems are not going to allow you to spin up that many native threads. Enumerators, when you do an enumerator next, that actually creates a fiber in the background. And that's been a challenge for us to scale JRuby up. You've probably all seen the talks on async and Falcon. Structured concurrency is definitely coming to Ruby, and that means many more fibers, hundreds of thousands of fibers that need to be in flight. We needed a better option for this. So luckily, the JVM folks listened to us. We begged them for years that we needed real fibers on the JVM, and now it's available in released versions of Java. Loom brings what they call virtual threads. They look like a native thread. The diff that I had to make to JRuby was very small, but now we can scale up to hundreds of thousands of fibers very easily, and it works incredibly well. We're very excited about this, and it's one of the reasons that we're considering making Java 21 the minimum for JRuby, so we can always rely on having virtual threads, real fibers on the JVM. One other big area that we're looking at on the JVM is improving the method performance of calling out to FFI, calling native libraries from Ruby code. So Project Panama is a project on the JVM that has now gone to production in Java 22. Project Panama provides a built-in native foreign function interface for the JVM. And the difference between the JVM's FFI and the one in JRuby is that the JVM JIT, the JVM garbage collector, knows about these calls and can optimize them. It can reduce some of the overhead of going out to native and coming back into the VM. It also comes with a foreign memory API to optimize accessing and allocating and clearing native memory blocks. Something obviously very critical if you're calling out to native functions. You need to be able to manage native memory as well. And our goal with this is to use Panama to try and make FFI calls just as fast as a Ruby C extension. We don't like C extensions. Maxime doesn't like Ruby extensions. Truffle Ruby doesn't like C extensions. Really, C extensions are the biggest thing holding back Ruby performance. It has been that way for 20 years. It still is that way today. If we can move more code into FFI or into pure Ruby, it will be better for C Ruby and all the implementations. And this is how we're going to try and help make FFI a viable option. Now, a classic challenge for JRuby has been startup and warm-up time. Now we look at this JRuby compiler pipeline, and there's a long distance from the Ruby code on the left to the optimized native code on the right. And when you think about all of the methods that are in your system, all of the Ruby code that's in your system, they each have to work their way through this pipeline to get full performance. Even worse, all of the Java code that's written actually goes through this same pipeline. So our parser, our compiler, our interpreter, all of the core classes start out being interpreted by the JVM. So it's very difficult for us to optimize startup time due to the way that JRuby and the JVM interact together. There's a couple new projects coming out. Project Crack kind of an unfortunate name. Coordinated restore and checkpointing, I believe. The idea here is that you can warm up a JRuby instance and get all of that code optimized and then save an image of it. Subsequent runs will start up almost immediately, and we can start to compete with JRuby performance. We're also looking at Project Leiden, which is going to bring ahead-of-time compilation to OpenJDK without breaking all of the dynamic features that JRuby needs. And there are JVM implementations out there that have things like JIT servers. So across runs, you can share JITted code and not have to go through that whole pipeline again. So looking at an example here, -E1, the simplest thing you could run in Ruby. Here it is with the same implementations of Ruby. JRuby 3.2 here, I believe, and not running with YJIT. YJIT can sometimes impact the numbers a bit on this. So, JRuby, designed to start up fast. Very quick, 53 milliseconds to do this. JRuby 9.4, without passing any flags, a little slower. And this is probably the biggest pain point. It's the number 1, 2, and 3 complaints for JRuby, for new JRuby users coming from JRuby. Startup time is a very big pain point for them. So we added a --dev flag. The dev flag turns off most of that optimization pipeline so that we can get to not the fastest code, but fast enough code a little more quickly. And this can make a big difference on a local system. But crack is really exciting. The checkpointing and restore feature can really improve this. We start to get close to JRuby levels of startup time. Looking at a larger command, generating a new application with Rails, for example. JRuby, again, very fast, 314 milliseconds, under a second to do this. JRuby, again, a bit slower, almost 6 seconds to run this. And it really just takes a while to get going. Then you'll see it run fast for the rest of it. But that initial startup is a big hit. Here, the dev mode makes a bigger difference. We're running more code. It takes longer in general. There's more optimizations happening. But dev actually speeds up quite a bit. And then again, checkpointing making a huge difference here. Once you get down under a second, most people aren't going to complain about JRuby startup time. So we're very hopeful that this feature gets into standard JVMs, and we're exploring it more and more now. Okay, so talking a little bit more about the future of JRuby from JRuby 10 and on. So I mentioned JRuby 9.4 is stable now. You can run anything that's Ruby 3.1 compatible. We have support for Rails 7.1. I think Postgres needs a little bit of work, but Rails 7.0 works great. JRuby 10 is coming this year. We probably could start putting out preview releases right now since we've been keeping up on compatibility, but of course, this new JVM stuff, these optimizations we want to do, we're very excited to keep working as long as we can to bring the best version of JRuby 10 that we can. And a big announcement here for the first time today, JRuby is going to be taking a bit of a new path. For the past 12 years, we've been sponsored by Red Hat. We're very thankful for the resources that they've given us over those years. They've helped us become a key part of the Ruby ecosystem to support those big production users. But we're moving on from Red Hat at this point. It's nothing to do with JRuby as a project. It's just their resources are being put into other things these days. We want to keep working on JRuby for you. I could certainly go and get a top-level job doing JVM, Java optimization, but it would mean less time that I can put into making JRuby better. So we are seeking sponsors or patrons to help keep the project going and keep us funded. We are also going to be doing commercial support for JRuby in production settings. We're still working on what this is going to look like, but there will be a JRuby support company. We will work with you to help get JRuby into production, to do targeted bug fixes, targeted optimizations. I have some ideas for new optimization work that we could be doing if we get this sort of funding. If you're interested in learning more about this, please contact us at support@jruby.org. We're going to be rolling this out over the next month or two. This is going to be the best way for us to keep JRuby a viable project, keep it part of the Ruby ecosystem. And that is about all I have today. There's some more contact information, places to find us, and please come and talk to us on our JRuby room on Matrix if you have any questions. And again, if you're interested in supporting JRuby or having JRuby support you and your production use cases, please email support@jruby.org. We're standing by to help make JRuby part of your company and run your Ruby code better. Thank you very much.